Since in the previous tutorial we prepared the terrain, in that tutorial, we are going to look at the Hardscape tools in the RhinoLands interface. Those tools are grouped next to the Vegetation tab. With the Wall tool, we create walls by specifying a thickness value and their height. We can adjust the smoothness if we are going to create walls from curved lines and control their justification with respect to the original curve. In the Material tab, we choose a texture to apply as a material. This material will be visible in the rendered view mode. Once its parameters are accepted, we can select an already created line in the drawing or create one using the options in the command bar, as well as through a curve. We indicate points in the view to generate the wall along this path. As you can see, the walls and other elements we will see automatically adjust to the surface of the terrain, as long as there is terrain at this same elevation. If I move it outside the terrain, it will respect the position of the curve. This automatic alignment can be disabled by selecting the wall, and in the options in the editing panel, we click on Do Not Adjust to Terrain. On the other hand, to adjust it again, we expand the Adjust options and choose one of the options. Adjust to a selected elevation, adjust to 0 elevation, or adjust to the terrain again. As with all lands elements, at the bottom of the panel, we can access and modify its parameters, as well as adjust the smoothness by increasing the number of divisions for the curved sections. Conversely, we can initially draw a line or polyline, like tracing the vertices created by the path. I move it 1 mm so that coplanar faces are not generated with the terrain, and I will create a wall again by selecting this curve. With a thickness of 0.2 and right aligned. We deactivate Snap to Terrain so that the curve fits perfectly and select it. To finish adjusting the position of its control points, I can isolate it in the view to select and align more comfortably. The next command we are going to see is the Ramp command. With this tool, we generate ramps with specific inclinations. In the first tab, we choose a construction method between masonry ramp, which is built as a solid structure from the base, or floating. We set a thickness for the ramp surface and also choose the method of joining sections. This will determine how the joint is made at the changes of direction of the slope in the ramps created from polylines. With landing, it creates a flat platform at the intersections, and with miter, it creates miter joints. If we select landing, we also control their extension, although it will never exceed the width of the ramp itself, so I set a value of 2. And also smoothness adjustments for ramps, curves, and the justification with respect to the original curve. In the Flight tab, we configure the width of the ramp and have the option to set different widths at the beginning and the end. And control the slope according to our preferred measurement system. Since it will have several segments, for now, I set it to a height of 0 and will adjust it later. We choose a different material for this element and accept. Before creating this ramp, I will cancel the command to extract the path curve again, as it will serve as a guide. I reconfigure the ramp and with the polyline option. I am going to redo the curve we used for the path operation on the terrain, but this time, without the vertices we created to make the landings. Once generated, I move it to align with the height of the terrain. When selected, the different segments obtained as a result of the created polyline are automatically listed. I alternately select to slope those segments that match the terrain's slopes. I am going to set a height for these of 0.48, which is the same value we used on the terrain. And so it fits perfectly on it. This command allows you to create various types of ramps. We can also obtain masonry ramps that follow a curved path, and with which we can control the smoothness and configure it with variable widths. To visualize the appearance and materials we are applying to each element, we must have the view in rendered mode. If we work in shaded mode, which is more advisable for good performance, we see each element with the color of its layer, unless we choose a different color in the General tab of its parameters. If we have any of the views in 2D, for the ramp, we will see that a series of arrows is also generated indicating the direction and slope value for each of its sections. To edit these arrows, we do so by selecting the ramp and accessing the Arrow tab, from where we can activate or deactivate both the arrow and the label, in addition to having style and color options for the arrow, and unit of measurement options for the slope value, text size, and its color. For the stairs, we configure their parameters in the same way. We accept and select a line in the drawing or create it. In its parameters to configure, on one hand, we have the dimensions of the slab and, independently, the total of the tread. If we match the two values, each step will be perfectly aligned. On the other hand, if I give a smaller value to the tread value, such as 10 centimeters, the steps overlap. Or if I give a larger value, we will have a spacing between the steps equal to the length resulting from the subtraction of these two values. And the same happens with the height value of the slab and its riser. Another option we have is to generate a variable width, with a starting value and a different value for the end, to create stairs like this, aligned on the sides or from the center. For the staircase section, next to the ramp, I hide the terrain layer. And from the view, in plan, I can make a linear dimension to measure the distance of the stairs. It gives me a dimension of 1.4 meters, so, divided by a tread of 0.28, it results in exactly 5 steps. And for the height, we could measure it from the front view, but I had already previously calculated it to fit a riser of 0.16 centimeters. So I run the stairs command again and enter these values, with a width of 3 and a justification to the left. I draw a line in plan from vertex to vertex in a straight line. And from the view, in perspective and using the Move tool, I shift it to its position from the lower left vertex to the vertex of the ramp landing. For the second flight of stairs, the parameters will be the same, so I can either make a copy of the entire staircase or generate just the line. Select the already created staircase, and in the editing panel, we have options to copy the properties of another object to this one or copy the properties to another curve. With this last option, if I select a curve, it will use it to create a staircase with the same configuration. The copying of properties is independent of the length or path of the curve. This option is also found in walls, ramps, and all the landscape elements we are seeing in this tutorial. If I take the properties of a different hardscape element, since they don't share parameters, the only thing it will take is the material information. Since we cannot create extensions on landings that are wider than the ramp itself. The space to cover, I can do it with a single step, with a width of 1. With a step depth of 5 meters. And I also adjust the tread value to accommodate a single slab. Now I can return to the terrain. I hide the stairs layer, which includes both the ramp and the stairs, and perform a cut and fill operation for the area under the stairs. Starting from a line between the two terrain vertices joined, I copy it at a distance of 3 meters. I join them in closed profile. Once joined, I copy them for the lower section. I do it this way, copying the first line, to ensure that this profile is coplanar, meaning that all 4 vertices are contained within the same plane. If not, it would cause errors when performing the cut and fill operation on the terrain. Before moving on to the next commands, I will add some additional walls. With a value of 0.10 and a rectangular shape, to contain the interior terrain areas. I position it, copy it for the other rectangles. I also create another wider wall for the other side, which will follow the profile of the stairs using a polyline. Fences are defined by the combination of 3 components: posts, balusters, and rails. The minimum element a fence must have is the balusters. In the Fence tab, we have the main configuration, and then we have 2 other tabs to choose which block we want to use for each component. We have the option to choose an object from the drawing itself as a post. Browse files to select another model if we have it in 3DM format. Or select it from the models in the block library. And also adjust its dimensions. We have the same configuration for the balusters, and once we accept, we create the path for the fence to follow. And we see in the fence parameters that we can configure the posts by distance between them or by the number of balusters. Among them, like every 2 or every 3. For the baluster, we can adjust the spacing between them and the elevation from the ground. If we want rails on our fence, we indicate the quantity, the profile dimensions, and the spacing between them, as well as the alignment with the fence. The material we choose for the fences only applies to the rails, as the material for the other elements is determined by their block. For this fence, I keep a single rail at a height of 80 centimeters. I deactivate the posts and generate a cylindrical shape of 80 centimeters in height, which I will select as custom from the baluster tab. To achieve this railing shape, finishing by adjusting some parameters of the rail and the spacing. I copy this configuration to another curve and create a second railing to fence the lower side of the ramp. The Path tool generates an extruded profile along an axis that adapts to the terrain. The profile of a path can be rectangular by specifying its width and height measurements or customized by selecting a profile already created or one that we draw at the moment. Whenever we use a selected profile, it must be aligned in the XY plane. If we choose to draw, we position ourselves in plan view to draw the profile, and when we have the profile closed, automatically, it returns to the insertion dialog. We accept and select or create, using one of the options from the command bar, the curve for its path. Paths have more detailed justification options, in addition to being able to center to the left, right, or center. Regarding the curve, we can align it with the terrain surface from the top, center, or bottom. For this project, I am only going to create a rectangular profile path that will serve as a sidewalk. To finish, we have a block library that provides us with a series of categories of urban furniture, where we find examples of benches, streetlights, trash cans, as well as models of people or rocks. When we locate a block that we want to insert, we just have to select it. We select an insertion point and then a second point that will indicate the orientation. Remember that by holding down the Shift key, we restrict the movement to 90 degrees. The blocks automatically adjust to the surface of the terrain. That's why it ends up a bit buried. To correct it, we can do it through a manual shift or by marking this surface as terrain. Select the block and click on Elevate to Terrain. In this library, in addition to the pre-prepared blocks, there is a section with suggestions of commercial product catalogs, which include links to brands that offer downloads of their models. If we select a product and click on Visit, we access the corresponding download page. If we have downloaded a block from an external page and want to incorporate it into the library, we open a new document. Click on File, Import, and search for the file on our computer. It must be a file compatible with Rhino in one of these formats, like this SketchUp block. And it's important to check that it doesn't contain geometry, materials, or any additional layers. This object should be placed on the default layer. If we want to change its materials, we need to do it now, before saving it. And it's also very important to check that it is correctly positioned and centered at the origin of coordinates, because when we insert it from the library, the insertion point is determined by the position of the origin of coordinates. So, for it to align correctly with the terrains, this point must also be aligned with the part of the element that comes into contact with the ground. We can use the Align tool, and when it asks us for a point to align the object to, we enter a value of 0. When we have it ready, we choose the Render Display mode for a more realistic preview. We position it in the center with the perspective we desire, and save it in a location of our preference, or in the location where the rest of the blocks of this category are found. We copy the folder path with Ctrl+C. Click on Save As, and paste with Ctrl+V in the top bar. We rename this file and save it as a Rhino file. Now, when I go back to view the furniture library, I have this new block available to insert. The added blocks. In this way, they will appear listed along with the rest of the furniture, and we will obtain their 2D representation automatically. To finish, we can insert rows of elements. From an element we select one that we load from our computer or from the block library. If we select the bench we just created, we draw a curve and indicate either the number of units of this element, or the distance between them. and we can center them on the drawn curve. From the Sample tab, we can change the block or adjust its orientation. We can also make combinations. If we increase to 2 elements in the selection area, the same bench now appears twice. We select one of them to change the sample to a trash can, for example. And by selecting the row again, I can adjust the parameters we've already seen and decide how they will alternate, such as a trash can for each bench every 2 or every 3, and some other alternative options. As you have seen, everything we can accomplish through these tools gives us a clear advantage, since we have editable parameters and an automatic 2D representation. This will make project documentation easier for us, also allowing us to extract lists and information for each of these elements. To conclude this tutorial, I will review the layer organization, redo some of those walls we had with the wall command, and finish inserting urban furniture and some people in this space. See you in the next tutorial with the vegetation tools.